Okay, let's begin with this question here. Okay, they say calculate m. So they're kind of like teaching the steps here by the writing, you can say. So they give you the sum of the series k equal to 3 to m. And then this is 1 over 16. And 2 to the power of k. This summation is given as 127.5. Okay, one of the tricks that we can actually do or employ in this thing is, because we have to think of that 16 there. You can actually take out the 16 out and bring it the other side because it's just a constant. That means that k equals to 3, m like that, 2 to the power of k, and then this one is 127.5. We modify it, just multiply the whole thing by 16. Okay, if we do that, we get a more simplified writing, which would be, okay, 127.5 times 16 is 2040. If my calculations are correct. Okay, this is 2040. Okay, using this, they want you to calculate. First, let's go for each of the individual components of the question. They say calculate the A and R. Okay, let's think about it from here. So first, let's try to understand what this means. This means that 2 to the power of 3k starts with 3 onward. 2 to the power of 4, blah, blah, blah. This is the series that's represented on the left-hand side. 2 to the power of m, you add them up, it becomes 2040. So that means that the first term, A is always denoting the letter A is the first term in such a topic. This is a standard, what we say, the notation. So 2 to the power of 3. So the first term is just 8. So the R here is, this is actually a, what is it? A geometric series. Okay, I must give a name here so it's a bit easy to remember. So geometric series occurs where from one term to the other, there's a multiplication by a common ratio or common constant here. The ratio here being 2. Because times 2, you get the next one. Times 2, you get the next one. You can actually compute the R as a ratio of the 2 to the power of 4 over 2 to the power of 3. That's how normally we do. Take that, let's say second term over the first term or any equivalent calculation like that. Third term divided by the second term, all that can. So in other words, it's just 2. The R is 2. Okay, here we go. We got the R and we got the value of A. So the first part is done. Okay, then we go for the second part here. What else are they asking for? 4.3.2. Okay, so it's 4.3.2. Okay, so here they're talking about what? So they say determine the number of terms. So the number of terms is a bit interesting because we look at the exponent. Okay, so there are a few ways you can do it. So I'm going to do a bit more of the formula way instead of doing the comparison way. So that at least we know. Okay, let's say the number of terms is n. So Tn is equals to 2 to the power of m. And then this Tn thing is by formula is Arn minus 1. And then this equals to 2 to the power of m. And n here is equals to the number of terms. Okay, please take note of the meaning and definition first. Now we just substitute the A is gotten from the earlier values 2. They always use the earlier part of the question without telling. Please take note of that trick. So 2 to the power of m. Okay, so we're going to solve this. So this is 2 to the power of 3. Make the exponents, the base of the exponents the same first. So here we would have something like 3 plus n minus 1, and then 2 to the power of m, or 2 to the power of n plus 2, 3 minus 1. And then here it will be 2 to the power of m. Okay, now we just equate the index. So when you equate the index, we would find that the n plus 2 equals to m. Or finally, the value of n, the number of terms is just m minus 2. So they want the answer in terms of the given letters. Please take note of that. That means they only gave a letter called m. So in terms of m, the number of terms is just m minus 2. Using the formula way. The other way is, of course, take the last minus first plus 1 if consecutive, referring to the m and 3 and the exponent there. So last is m minus the first is 3 plus 1. You get immediately m minus 2. So such a shortcut is for consecutive numbers to count how many consecutive numbers are there is used in the mostly in the competitions. It's like a shortcut. Please take note of that. Okay, now we're ready to calculate the value of m using all these, what we say, preliminary calculations. Okay, so that means the value of m means I'm going to take this part and link it to this part, because they are m minus 2 terms, means the sum of the first m minus 2 terms is given as 2040. That's how we interpret this. So a equals to, the first term is 8, and the r, common ratio, is 2. Okay, now that means we need to use the formula. What is the general formula for the sum of the first n terms of a geometric series? Aha. So it should be a r to the power of n minus 1 over r minus 1. Okay, let's try to simplify this first. So with the substitution, this would be 8. So 2 to the power of, the n here is m minus 2. Please take note, number of terms, like that. And then just substitute accordingly. R is 2 minus 1, A is 8, 2040. So it just becomes a bit of, what do we say? A calculation. Aha. To the power m minus 2 minus 1, like that. 2040. So let's try to solve this equation please, to see the value of m accordingly. So just multiply. This times this times this. And then 8 times 2 to the power m minus 2. This part becomes minus 8, 2040. Bring it the other side. Change it to exponent on the left. So this should be 2048. Okay, 2048 will definitely be a power of 2. So a little bit of, what is the word? Experimentation with the calculator, or trial and error. You should eventually find this as 2 to the power of 11. Okay, you can suspect that by the left-hand side being purely in the base or base exponent of 2. So then we add the power. So this will be 3 plus m minus 2. And then this equals to 2 to the power of 11. Oh, so equate index. Equate the index means only the power part, this and this. So 3 plus m minus 2 equals to 11. So that means, aha, m plus 1 equals to 11. Or finally, we can calculate the value of m as, m is 10. That's the answer. Thank you.